Here we go. And so one of the things we did in class last Friday is we geocoded. Geocoding is when you turn a relative location like 27, Main Street, Durham, North Carolina, and turn it into an address on a map. And we do this all the time with our handheld devices. And I think we're starting to get a better appreciation as to the time, effort, and technology that goes on in the background so that we can go through and do this. Now, a couple things that I have right here is when I go to view catalog pane, and catalog pane used to be a separate standalone application called ArcGIS Catalog or ArcCatalog, which was a separate application, kind of like Windows Explorer, so that you can cut and paste and move things with the little windows and the folders. And I also did this for GIS, and now it's kind of been built in to our ArcGIS Pro software, but we can just navigate our maps, toolboxes, databases, and all this other stuff right here. And so we can add new databases, add new files. We can add new folders to our project, like add folder connection, saying, hey, I don't want to look at exercise 3 folder. I want to bring up my stuff from Mulrooney's data, which is kind of my data repository as well. The other thing that we can do is we can add locators. And here, if you click on this, you can see I've got my locators right here. I've got an XY provider. We're going to talk about that next. We have an NC geocoder. But remember on Friday when I ran that NC geocoder, we only matched like 45 out of the 152. We only matched about 45 out of the 152 addresses. And so we probably have to go to NC One Map and look at the geocoder and see, all right, what is the format that it needs it in? Meaning, hey, it just wants it all in one field, where here in our world geocoder, it's got multiple fields. To add this geocoder, and I went through this the other day, is that I've got a number of favorite services. Okay, services are files, applications sitting on someone else's computer far away. We actually have cloud-based services sitting right here. There's FMXV, BFCLF. Who wants to? No, we don't want to do all that, but that's the unique identifier for it here. But I've got these ArcGIS services sitting right there, sitting under these geocode services. And if I look at the properties, I can add it using this URL, which is https geocode.arcgis.com arcgis/services. And so if you're watching this video right now, you can go and type that in under add new ArcGIS service. And now I can just go to world and click OK. Oops. But I can go to world and then add to project. And now it's sitting here under this project. So now when I say, hey, go to your geocoder, this world one is sitting right there. A couple questions here is, did all these things match up exactly where they were supposed to be? No. Why? Because some of them didn't have absolute addresses. It said something like Irving Street / Main Street, and it probably just stuck it on one of those streets right there. So you as a crime professional, what are you going to have to do? You're going to have to go through and go in. Now, I'd probably go to like a secondary source like Google Maps or something like this, because these have their own services. But I'd go in and basically look up where these are. And there was about 12 of them or 9 of them that didn't match up just because of some of the inconsistencies with the address here. You know, East Main Street. Where is East Main Street? I don't know. You got to look that thing up. Okay, so we've got this here. And so I've got some questions related to this. And so we complete those. What are all the fields that we need? We had something called address. We had something called city. And it figured it out for us. Okay. And then we look at number 6. Of all of them, why did we have some errors? Because probably the arresting officer didn't have an address. They just put into the field something / or this happened on, Interstate 85. Can you find an address on Interstate 80? It's probably really hard, because when we look at these geocoders, typically we have addresses that match up to this. These are called LRSs, or line route segments. They'll have a beginning address and an ending address. And most of us think like these are used for like mail. You're not going to be delivering mail on, Interstate Highway 85. And so probably a lot of times Interstate I-85 isn't going to have addresses attached to their attribution, their fields right there. And so we need to kind of think critically about how those look. All right, so briefly describe where the homicides occur. So when we look at this here, where the homicides occur, can anyone tell me? And this could be really general. Where are more of the dots than less of the dots? Because we're not going to talk about any kind of quantitative information right now like we talked about last time, but where do a lot of these dots occur? Probably right downtown, maybe a little bit on the east side right there, but these are all the homicides, 152 homicides. We need to understand a few of those might not be exactly correct, but a majority of them are. So try to describe where they are. Any type of description, would be great. I'd probably just say, hey, over near I-70 and 785, a little bit north of Research Triangle Park right here. We can describe the actual locations right here. It looks like there's a good section of homicides that kind of occur on Holloway Street, east of Main, kind of right over here, if you're familiar with those. Or we have some right here, a little bit north of campus right here. Here's a healthy neighborhood right here. And then as you cross over Lawson Street here, you see there's 5 of them sitting right there over in McDougal Terrace, which is probably a dozen acres in size. But you can see NCCU campus right there, and a little bit north in the Hayti neighborhood here. But then you get a little further south over here in College Heights, going in that direction, probably not as many. And so you can just describe where they are, because we'll talk about quantitative ways to look at these. All right, number 8. Now I have a table of all crimes that occurred for the months March, April, May, June 2019 versus 2020. I want to create data using the add XY data. Okay, and the question says, what attributes from these fields represent X and Y? What do you think these units are in? Okay, so what do I want to do here? Now, if I right mouse click, and this is part of a project that a former criminal justice major did, William Satterate. Does anyone remember him? Well, there's a lot of criminal justice majors, but he was a non-traditional student, spent a lot of his adult life in another career, came back and did criminal justice, and came over to our department so he could do this project. And this project was basically, I want to see to what extent changes in crime occurred between 2019 and 2020. And some of the interesting things that he saw, and I think his presentation and his thesis, his master's project, we put as a link here. And basically we saw that crime went down, but like different types of crime like domestic violence and assault actually went up. And so you're kind of stuck at home with people, and you probably get really annoyed with them, and it manifests themselves in these different types of crime. So the violent crime, certain parts of violent crime actually went up, while that general crime went down. And remember, when you go to the Open Durham website, because at some point in time, you're going to be the one either contributing to Open Durham or utilizing the data from Open Durham or Open Raleigh or Open Greensboro. And I bet you even smaller municipalities have these open data sites. Open data is really big these days, because at the end of the day, who pays for all this data? We do, you do. So you better have access to it, or you hope you have access to it, and especially non-private data as well. And so what we've worked to do is make sure that people have a means to access the data. Now, is everyone going to be able to do this stuff? No, you're taking my class, and now you've got the skills in order to make the maps and facilitate some of the spatial data-driven decision making in order to do this. In addition, something like offense, towed abandoned vehicle. Is that really an offense? Is an important offense as something like vandalism or drug narcotics violation? And we talk about kind of maybe some of the decriminalization of this as well, as opposed to simple assault or aggravated assault or larceny. And so we can put like values on these to see, quantitative values on these to see which one has the worst crime or the most crime, or the part one and the part two crimes, because we can just do nice queries and say this crime, this crime, this crime, this crime, these are part ones, everything else is part two. So we can look at part one crime rates versus part two crime rates. And we learned how to do that, or at least learn how to run the queries in last chapter. And so we got these crime rates right here. But when I look here, we have an offense and address. We also have X and Y. Okay, if someone gives you the X and Y, you map the X and Y, because we just saw if we were to map 12,000 crimes, how many of them do you think are going to be incorrect? What percentage of those homicides were incorrect? Just because of maybe misspellings or the improper address was put in there, or an incomplete address was put in there. There's probably about 10% of them weren't even put in there. You got to go hand jam those last 15 or so. And so 10% of 12,000 is about 1,200. Who wants to go and hand jam 1,200 addresses? No, I don't want it. I definitely don't want it. And so they've got an X and a Y right there. What do you think William and I did for our paper when we ran the geocoding and we had like 12,000 addresses that didn't match up? I didn't go and redo them, and he didn't go and redo them. So at the end of the paper, and when we put in this thing called discussion at the end of the paper, says, hey, when we ran it, we had 8% of the addresses didn't match up. So in reality, that might change certain areas. Maybe the arresting officer who takes care of this part of the city here, they might not put in, they might put in incorrect addresses or unreadable. I don't want to use the word incorrect and besmirch anyone, but they might always put in the intersections right there that can't be read. So maybe that, the person in charge of this beat right here versus the person in this beat always make sure they have a proper address right there. Who's going to go and check that? Not me. I'm not going. That's why they invented students and grad students and researchers and all that other stuff. Okay. If we wanted to, we could go through and run those corrections. But for this, we're not gonna. When you go out and get yourself in the workforce, that's going to be a little bit more of a problem here. No, or a little bit more of a challenge that's going to be put on your plate. And so if we have the X's and Y's, we take advantage of these. And so that question from the exercise says, all right, we've got some X's and Y's right here that we can measure down to the nearest. I don't know what unit this is, but what units are these in degrees, first of all? No. How do you know that, Alondra? It's a really big number, and degrees go from -90 at the South Pole to +90. We work with degrees, minutes, seconds. We work with decimal degrees, and these are actually in feet here, because you see these numbers right here. This is called an easting. This is called the northing. And you kind of look at these units, and they kind of, like these numbers, we're looking at like 2 million, almost 800,000 right here. These numbers kind of line up. And so this is what we call the North Carolina State Plane Projection, so that we minimize distortion for the state of North Carolina. I played a little with that before, but we stick some 0 point way down in Alabama. It's actually in Alabama. And then everything in North Carolina is positive. Remember that first quadrant stuff from math class way back in the day? So we've got everything's a positive number. Now, if I had negative numbers here, they'd be in other parts of, the United States, but Alabama has its own coordinate system where they have their 0 pointer or whatever else. But these are really easy to match. And so the only trick that we have right here is I right mouse click, and then you're going to see display XY data. If you're working with newer versions of ArcGIS Pro, you're going to see something over here. I think it's like tabular data, work with tabular data. It's just slight difference right here, but it's called display XY data. Display XY data, and this is really simple. I swear it's simple. Okay, so we have our input parameters here. What's the X field? X. What's the Y field? Y. Now, if we had a field here called northing and easting, well, easting is going to be our X. northing's gonna be our Y, right? You know, because remember, north, up, down, you know, latitude. Okay, where longitude's the other direction. Now, the only thing we need to worry about here is the coordinate system. So I need to go and find the right coordinate system. So I can click this little world, and then I can find the coordinate system. Now I have a bunch of favorites right here, but I can go down to projected coordinate systems, state plane. We work with US feet. And then here we go. I can go to North Carolina. Because you know what I'm going to do? I'm going to do a couple of wrong ones, and we're going to see what wrong data looks like, and then you won't make the same mistake again. Now, how do I know this is right? Look, it popped up right on the map here. And so these things superimpose on our existing map. We know, because this computer's stupid, you know, and I don't mean that in an insulting way, but we need to tell it what these numbers mean. We need to tell it these things are in feet. If we tell it it's in degrees, it's not going to like us, because this thing doesn't know these columns are in feet. Just like we don't know, it doesn't know what this thing is. And so we got to say, hey, hook up with this geocoding service and do your best to match up with these things here. Even though it says Durham Chapel Hill Road, it's probably going to stick it right in the middle of Durham Chapel Hill Road, even though we didn't give it an address right there. And so I'm going to show a couple of possible errors that we can have, and then we'll kind of circle back to what we're looking at here. Because this is what you're going to be doing as a crime professional. Someone might give you the X and Y. Previously, when we worked with the city, they just gave us a big DBF file, database file of every crime and the northing and the easting for it. Not the latitude and longitude, the northing and the easting. And so we can do this. Now I can right mouse click, and I'm going to uncheck this again, because to me, the best way to get things right is to get them wrong, you know, because you remember the errors a lot more than you remember your successes. And so messing these things up or making mistakes, and obviously not intentionally, but making mistakes and working through these problems really helps develop you as a problem solver. Because you working for the city of Cary, how many city of Cary crime analysts do you think are out there? Just one. You know, so you don't have some mentor to look up to, maybe in another city that you might meet or whatever, or the Google Forms or the Esri Forms, but you're going to be the line of defense here, you know, where, hey, I don't have the X's and Y's. We need geocoders. We need to figure all this stuff out. And this is what we call data wrangling, meaning how do we kind of turn all this stuff into spatial data that we can query and make nice, pretty maps of. So we've got this display XY data. XY, hey, look what happens if I display it. Because remember, when I opened this thing up, the default was geographic coordinate systems, latitudes and longitudes. What happens if I just say, okay, yeah, X, Y, because me, I'm a big next. You know, I open up a tool, just next, and then, oh, this isn't what I think it should be like. And so I run this. What happens? Some features have invalid geometry and have been removed from the result. Let's see, how many of them? 1, 2, 3, 4. You know, look at them all. You know, all the way to 12,000. Okay, and so like Alondra said before, this computer's smart enough to say, you know what, this isn't a degree, this isn't a valid degree, we're not doing this. And the last thing we'll do, and these are some of the things that I did with when I worked with the military. Way back in the day, they like to work in meters. I don't know why. These state plane coordinate systems. And so when I go display data, and I do my X field, oops, and my X field is my X, my Y field is my Y, and then I go down to projected, because a lot of times this used to be a lot of trial and error, especially if we're working with old data that we're not familiar with. And I go to state plane, and I work with meters instead of feet. What do you think is going to happen to this thing? This is really funny. This is going to be really funny. All right, so I'm going to run it. Oh, it's going to display. Wow. What happened to all my crimes? Where'd they go? They went in the ocean. Why? Because how big is a meter compared to a foot? It's about 3 times more. So we moved it like 1, 2, 3, 1, 2, 3. So now look at where all the Durham crimes occurred. They occurred in the middle of the ocean because we changed it from feet to meters. And so a lot of people, especially back in the day when I started with GIS, someone would just say, "Oh, okay, guess they all occurred in the middle of the Atlantic Ocean. Let me go to the next one." And we were going to be working with incorrect data. And I like showing these because we know this is this is an incorrect answer. Okay, so I'm going to remove this one right here and get rid of this. And so you can kind of see the multifaceted question that I have right here in that what attributes do you need? X and Y. What do you think these are in? These are in feet because I just showed you if you change it to meters, that's what's going to happen. It's going to stick it in the middle of the Atlantic Ocean. And so way back in the day, and we're looking at more than 20 years ago, we would work with data file or even imagery that didn't come with a projection file. We'd have to kind of play trial and error to figure out what projection it was in. And Cherry Point, has anyone heard of Cherry Point? It's out actually past Morehead City. It's a Marine Corps air base that utilized Marine Corps air base. And for some reason or another, the people there worked not with state plane, but they worked with state plane meters instead of state plane feet. And then like places in upstate Michigan, they would work with this weird like Upper Peninsula projection, even though they were in the lower peninsula. So you'd get these really weird units for X and Y or whatever they called them, and we'd have to kind of figure out which one worked, just like we do kind of here. But for the most part, like Alondra said, hey, these things don't look like degrees. Let's go with feet first, and then let's start taking some guesses because we got continental systems, meaning, hey, I want to minimize distortion for the entire continent. All right, let's bring in that system to see if that works so that all these crimes, because we're smart enough to know where they should be superimposed. So that's kind of where you all start to learn how to, stop, you're not going to find this stuff in a book, and we start working from there. All right, next thing we have, I have a table of all crimes. What attributes do we need? Number 9, I want to create an updated NCCU campus map to include all buildings. How many buildings, okay, do we have here? And so I'm going to zoom into my buildings because what I'm looking at here are all my crimes. Uh-oh. Did I? Oops. I think I kept the wrong feature class. Oh, wow. That is funny. All right. Catalog. Databases. I think I got rid of the wrong thing. Remove. Okay. That necessary? Okay. We're going to do this one more time. All right. Display XY data, XY, state plane. Oops. Oh, I know what I did. It looks like I overwrote it. State plane, there we go, sorry. Okay. So what we're doing here, well, look at this like batch of crimes right here. Look at that. You know, what's going on there? I have no idea. Those are some things we can look into. We can also start to look at things like clustering or whatever there. And so I can right mouse click zoom to layer because what we're looking to do here, this is around the NCCU campus right here. What's the definition of the NCCU campus? All the buildings, right? The buildings. So what is one thing that you see about the campus? And I can change my base imagery. So I can go to map, base map, because I see Alondra pop this thing up already here. I'll change my base map right here. What do you see about this? Yeah, things aren't updated. And I'm going to change the crimes. I'm going to change these things to red so they're not green anymore. Okay. I'm still getting used to the imagery editor. Come on. We're just going to make these red dots. How's that sound? Okay. Okay, so now we're going to look at NCCU campus. And really, if I want to find every crime within 1 mile of the NCCU campus, it's going to be within 1 mile of all these yellow buildings. Is that truly 1 mile of campus? Because look to a little bit to the north. I've got that new business. The new business school of business. It's called the School of Business, right? The new School of Business. So I've got a new building up there. If I look to the left, over here, I've got the Bright building that we've got right here. Okay, I've got this building right here, the new Lawson Street Apartments. Okay, so basically within 1 mile of campus is just within 1 mile of the representation of the data that we have. Have we been able to find, can we find data within 1 mile of buildings? We did this last, that's what we call the spatial query. So I want to do that now. And I'll do a kind of quick test right here. I can do map, select by location, and I bet we're going to have a different number. If not, I'm going to look really silly. All right, so I have DPD, not homicides. Oh, Irene, crap. I gave it the wrong name. It's supposed to be, man, okay. I just don't want to confuse us joining us online. Buildings all, and we're just going to say 1 Sechimo. And so all these crimes right here, all these crimes right here, 1,553 are within 1 mile of the NCCU campus. And I can click this little building right here, and we can see when they were, what they were, and all that other good stuff. So this question here says, how many buildings are in this feature class right now? Because I'm getting a little off topic here. So I want to update these buildings. How many of them are here? Right mouse click, open attribute table. I see 56 of those. What are some of the problems you see? They're not all updated. They are not all updated. And so what we can do is we can set up an edit session, and it's been made a lot easier these days so that I can just go and start to trace brand new features to represent these buildings here. So we're going to edit, okay? And we're going to go edit, and you're going to get rid of buildings and add new buildings. And I'm pretty sure Alondra did this last spring, right? And this is even new database too, because it didn't have the School of Business. Because I think previously we were working with 63. So I can go to edit, and I can go to select. And so now I can go and get rid of this building right here. And I can click on it. Do you want to delete data? Yes. And guess what I just did? Instead of 56, how many are there? 55. And so I can go to map here. And now I can go to edit. I want to create a brand new feature. I want to create a building. What do I want to do? I want to create a brand new polygon right here. 1, 2. I'm putting in the outline of the new business building that was just like dedicated last week. Now I'm up to 56 buildings. Okay, what can I do down here? In the attribute table, what can I do? All right, I'm going to double click. School of Business. And I can put all the other information in here too. Let me go trace a new outline here. What's the name of this one here, right on right on Alston Street, Alston Avenue? This is Chidley. Didn't there used to be another Chidley? They just gave it the same name. Chidley Residence. Well, Chidley Residence Hall for now. Wait, what's this one right here, right next to the? Is that another Chidley or is that something different? This right here?
No, that's Richmond.
Okay, Richmond. Okay. And under edit, while I'm working on these, there should be a save button. I got a save button right here. And so what I'm going to do is I'm going to go and edit all of these buildings. So now I went from 56 to 55 to 56 to 57 buildings. And I've typed in the appropriate information. Okay, if I really wanted to, not really wanted to, but I can calculate the number of acres. So I can right mouse click. I have something called calculate field, but I can calculate the geometry. Do you think I'm out there with like surveying equipment calculating the number of acres? Of course not. So acres, US acres using state plane. So right now the school, oops, not oops, but I got to highlight those. Or I can highlight everything. But now you can see the new student center that I calculated before has about 1.26 acres in size. The School of Business is about 0.667. If Alondra were to go and measure it, do you think it's going to be the exact same as what I calculate? No, because it's only as good as the person calculating. And now under map, I can do select by location. I run this same exact query again, and I'm going to clear this thing. Map, select by location. Remember we had 1,255 before. Intersect, buildings all, 1. Okay. Now this is everything within 1 mile of campus. Remember I had 1,255 before? Now I have 1,593, slightly different number. Why? Because I started getting new buildings that are going to increase or decrease that buffer. That's pretty cool. Now this digitizing. So what you're going to do is you're going to use set up an edit session so that you can add all the new buildings, give them new names, zoom in right here. You got your George Street apartments. We can go get rid of Baines and whatever you want to do here. Now, for a project like this is really, really fun. But when you start like digitizing homes around Army installations, it's not fun. And it gets really, really boring really quickly. I used to just cut and paste, cut, paste, cut, paste, cut, paste. Because on these maps at 1 to 25,000 or 1 to 50,000 scale, they're just going to look like little black dots. So no one's going to say, oh, you messed up that rectangle because it's so zoomed out to begin with. But here, we're looking at 1 to 6,000, so zoom in, and even you zoom in better, and someone can say, hey, Mulrooney, you really, look at that thing. That doesn't look so good, when we're down at a scale of 1 to 659. And so there's some people whose lives basically exist in editing spatial data, whether it's working with parcels. We had another project right when I came here where that we were digitizing impervious surface. What's impervious mean? Water can't pass through it. Why would anyone care, and why would anyone give money to figure out where all the impervious surface is?
Because that leads to flooding.
Leads to flooding and runoff. Exactly. So we could start to figure out where there's more flooding and runoff. Because if water hits grass, what's it going to do? It's going to infiltrate and percolate into the ground. It hits the parking lot. What's it going to do? It's got to figure out somewhere to go. And so a lot of times with roads, if you just have really flat roads, where's that water going to go? It's going to stay there until it gets evaporated, which is going to have, what is it, hydroplaning or something like that? Is that what it's called? I don't know. It's something I remember from driver's ed class. You know what I mean? But I don't call it hydro. I call it holy crap. I'm fine. So things like that. Over in Greensboro, we used to have a house in Greensboro, and we were charged for the amount of impervious surface that we had, based on our driveway and roof. And why would they charge you more if you had more impervious surface in the city? And that's probably what they're doing here in Durham. Why would they charge me more for more impervious surface? If I had more impervious surface, what was I doing? I was contributing more to the runoff. And so the less my field, the less amount of area my yard was taking in water, the more that the city had to figure out what to do with it. So if I put like a patio out back or out front or something like that, like, hey, that's another 20 square feet of area that the city needs to figure out what to do, as opposed to it just going into the ground and feeding my plants and trees and all that other stuff. Pretty interesting stuff here. To me, it's, really, really interesting here. And it really ties in with, environmental science and all that other good stuff. So how many buildings are in the feature class? I'm going to leave number 11 for you, because we're going to look explicitly at motor vehicle thefts. Okay, and I know I think I created this problem for a couple of folks that were looking at motor vehicle theft. So what we're going to do is the same process, but we're going to query out motor vehicle thefts for 2019 versus motor vehicle thefts for 2020. This might be something really good for us to do as part of our project. This question 11 might be the beginning of a project. What happened to motor vehicle thefts during COVID? Okay. And so we're going to do the same thing. We're going to add XY data for 2019, add XY data for 2020. We already got the 2019 data sitting there that we went through and did. Do the same thing for 2020, query out motor vehicle thefts. And then what did we say here? Within 1 mile of campus. Can we do this? You bet we can. If not, ask Dr. McGinn on Wednesday when he's here. But that should be fairly easy to do. And so we can really prove or disprove, make some really simple hypotheses that we don't need to get into statistical testing or anything else. A lot of times, and I probably push it a little too much, is that I love talking about the t-tests and all that other stuff, but we start our semester with talking about just descriptive statistics, meaning more, normalization. And a lot of times when we talk about normalization, it means making sure you're comparing apples to apples. Motor vehicle thefts within 1 mile of NCCU campus versus 1 mile of NCCU campus for 2020. One year was 21, the next year was 28. It went up. You know, we don't need t-tests or any of that other stuff because we're comparing the same exact area. 1 mile of NCCU campus versus 1 mile of NCCU campus. And so I think we can do some real simple hypothesis testing to do this. You know, how does it look? And then later we can start to look at, all right, how does it look at outside of campus? That's where we start to compare apples and oranges, meaning, hey, let me look at everything within 1 mile of NCCU campus, because it might be 21 versus everything else outside of campus might be, 126. But if the area within the NCCU campus is 10 times smaller and it only has 5 times less motor vehicle thefts, you could probably say, hey, the rate is twice as much. And so we can start to think bigger picture about normalizing data and keeping those things on a level playing field. And so I've got a couple more questions here that I just want you to kind of start thinking about. And I did talk about 11 a little bit, about just what would happen. And we saw what would happen. If I added the business building to the NCCU campus, what did that do to the number of crimes around the NCCU campus? Why? Because basically we've expanded campus a little bit, so that 1 mile buffer area is going to be a little bit bigger. It just gives us an extra 50 crimes, but that's what it gives us. We're really data driven in this class here. So I'll end it today here, and then we'll Dr. McGinn will kind of come in and tidy up some of the loose ends, not only with this, but also on applying this stuff to some of the things that we see in the real world, so that we can really get some good ideas for some projects and everything. So I'll see all of you later. And we should be good to go. And this will be due in a week from Wednesday. And I think we've got a good basis for this. All right, thank you.